Okay, so we're just looking at the titration example question. That is the last question, or on the second to last. Sorry, it's on the second to last page of the preparation booklet. So the scenario we're given here is that a laboratory assistant wishes to determine the concentration of an acid, which is sulfuric acid, that has been stored in a bottle inside the corrosive cabinets for several years. A standard solution of sodium hydroxide, that's 0.2 mole per litre concentration, is used as the titrant. So obviously the titrant, so what goes in the burette, we know the concentration of it, we put a variable volume into our conical flask until it neutralises, till it reaches that equivalence point. Sodium hydroxide reacts with sulfuric acid as shown in the equation below. So obviously for every 2 moles of sodium hydroxide will neutralise 1 mole of sulfuric acid. Sodium hydroxide solution was transferred to a burette, and then a 20 ml volume of dilute sulfuric acid was transferred to a conical flask using a volumetric pipette, which we know looks something like that. So just before we look at the actual calculations here, let's just think about our experimental procedure, as that's something that you will be tested on. Sodium hydroxide was transferred to the burette. So how do we prepare a burette? To start with, we get our burette and we are going to rinse it with distilled water. Why do we rinse with distilled water? Have a quick think about that, maybe pause the video for a second, have a think about it and then resume. So we rinse with distilled water to remove any contaminants that are present in the burette, just to clean it out. After that, what's our next step? So after that, we're going to familiarise the burette with the solution being transferred in it. So what that means, we know that sodium hydroxide is going to be, used as our titer, it's going to be in the burette. Therefore, we're going to run some sodium hydroxide through the burette to familiarise the glassware. And why do we do that? Again, have a pause and think about it. So we do that because there's going to be residual water left in the burette, little droplets all the way through it. Run some sodium hydroxide through, remove that residual water. So now any residual solution is sodium hydroxide. Therefore, when you fill the burette up, you're filling it up with sodium hydroxide. Any sodium hydroxide that was present in there, as residue, it's not going to affect the concentration because it is the like solution. Obviously, if we left water in there, if there was residual water, that would dilute the sodium hydroxide slightly, lowering the concentration of the solution, increasing our titer values, and then, systematically skewing our results. All right, so sulfuric acid was transferred to a conical flask using a 20 milliliter volumetric pipette. So again, volumetric pipette, the one I drew earlier. How do we prepare that? Rinse it with water for the same reason, to remove any contaminants, and then rinse it with the solution being transferred, but in this case it's obviously the sulfuric acid. For the same reason, any residual water in there will dilute the acid. If the residue is sulfuric acid, then we don't change the concentration of the acid. Alrighty, titration was performed 5 times and 3 concordant values were titrated. 3 concordant value titers were obtained. So what does concordant mean? It pretty much means that all of our results agree with each other. In terms of titration, it's normally that they're within 0.1 of a milliliter. But just think of the word concur. Concur means to agree, so concordant means the values are the same, they agree with each other, etc. So, calculating the average titer using the 3 concordant values. So choose 3 concordant values that are all the same. Obviously 2, 3 and 4 are suitable. Therefore your average titer, which I'm just going to call V average, is equal to 10.1 plus 10.0 plus 10.1 divided by 3, and that's going to equal to 10.06666 recurring, which I would just write as 10.067 milliliters, but obviously you want to use this figure in your calculations all the way through. Alrighty, determine the average number of moles of sodium hydroxide in the average titer. So we know that our concentration from up here was 0.2 moles per litre. Our volume is our average titer, which will convert that to litres, which will be 0.010066666, etc. We're going to use that full value from the calculator because, make sure our results are accurate. We know that N equals CV, therefore 0.2 times by 0.0100666, etc. equals 0.002013 moles. Lovely. That's again a rounded off answer from the calculator, but we're going to use the full carrying answer from the calculator for our results. All right, so up here in our equation is going to help us for the next question. So determine the number of moles of sulfuric acid present in the 20 milliliter sample in the conical flask. So first off, we know that the number of moles for sodium hydroxide is that number we just worked out, 0.002013. For sulfuric acid, from our equation, we can see that the mole ratio for every 2 moles of sodium hydroxide, we need 1 mole of sulfuric acid. That therefore means that we need half the amount of sulfuric acid, or half the moles of sulfuric acid per sodium hydroxide. So the moles of sulfuric acid is going to equal to half of the moles of sodium hydroxide. That's obviously equal to half of that number from the calculator. And that's equal to 0.00100667 moles. Hence determine the molar concentration of sulfuric acid. So we're told up here that a 20 milliliter volume of sulfuric acid solution was put in the conical flask. So therefore our volume is 20 milliliters, which we're going to write as 0.020 litres. Our concentration, we don't know because that's what we're trying to determine. Our moles equals 0.00100066, etc. from up here. Therefore, if N equals CV, C equals N divided by V, C equals 0.001 ... divided by 0.02. Therefore, C is going to be equal to 0.05033 moles per litre. Now, if we want to talk about significant figures for that final answer, the sodium hydroxide was given to 2 significant figures here. The volume was given to 4 significant figures here. Volume again, 4 significant figures here. Therefore, we can see that the smallest number of significant figures was 2 from the sodium hydroxide solution there. So if we wanted that to 2 significant figures, if you were asked to, it would be to 0.050 mole per litre, with this here and this here being our 2 significant figures. These 2 do not count as significant figures, these 2 do. Beautiful. Any other questions, just send me an email, or if there's any other questions you want me to run through a video, feel free to ask on an email and I'll try to find time to. Thank you.